Ladies and gentlemen, my name is Jason, and you are at WordCamp 2025 in Vienna, Austria. So if you're in the wrong place, please leave immediately and check at the help desk. I'm here with Dennis Snell, and he's quite notorious as someone who makes things that don't break but fixes things from people who does. So more or less, he's going to talk about the HTML API. So please give him a big round of applause. Dennis.
Thanks, Jason, and thanks everyone for coming. If I'm hard to understand, please just raise your hand or whatnot, and we can try and adjust. I thank you for coming at this end, towards the end of the day presentation. I myself am a little tired, so if I see you sleeping, I'm just going to assume it's because of that. Who here has had the chance to work with the HTML API? Excellent. About more than half the room. First of all, I'm sorry, but second of all, I hope it's been useful to you. This is always a little bit of a treasure for me because a lot of our first announcements at WordCamp about HTML API has happened here in Vienna. And I really appreciated the way the last presentation ended with questions about headless WordPress and blocks. Was anyone in the room? Well, sometimes blocks are hard to work with on the server because all the actual information in the attributes is embedded within the serialized HTML. Well, there's a correlation between that and the HTML API, something I want to explore today with the topic of doing more with less. So just to kind of motivate the talk today, a little bit of did you knows. Did you know that the HTML API in core for some number of months now has been able to change the inner and outer HTML of a document? It's able to render HTML templates in a safe way. It's able to normalize documents so that you get everything all proper and escaped and all tags are there, no overlapping or missing tags. You can use the HTML API to create actual XML or XHTML. If you have ever had to work with existing WordPress conversion to XML, it's scary. And you can read block attributes on the server and do things like migrate old block markup in the database. So it's been a long time coming. I mean, like this has lagged Gutenberg data format quite a number of years. But today in core, you can do all this stuff. And we're going to go into that. So this is kind of a fairly technical talk. I hope that we can follow along. But again, if you have a question, please interrupt. I kind of like the exchange with the audience. I like to know that we're kind of syncing together. Quick review of the development of the HTML API. It was first introduced in WordPress 6.2, and we've been adding features and functionality to it ever since. Obviously, as many are aware, automatic paused contributions to WordPress core recently, so WordPress 6.8 doesn't have that much activity in it, just some lingering work. But we got enough in there before the pause that pretty much everything that you'd want to do, you can do with a few trade-offs. We have working code to handle pretty much everything that everybody wants, but as we look at this timeline, we don't put anything in core until it's solid and ready and trustworthy and there's no gotchas. Obviously, because there's bug fix, that's not entirely true. But inner HTML, outer HTML has some gotchas we're going to look at in just a moment. That being said, let's take a look and see how we can do some stuff. There's an infamous Stack Overflow question on the internet that starts out friendly, gets faster, gets more aggressive, and ends in a giant jumble, and it says just use an XML parser. Who's seen that? There's a great irony in this Stack Exchange answer. Anybody know what it is? It's terrible advice. because XML parsers can't parse HTML because they're two entirely different languages. HTML predated XML, and they have different semantics. So when we talk about safety, we usually think about regular expressions or string replacements, and I think it's well established now that the HTML API is here to eliminate the use of regular expressions. Sometimes people say use DOM document. We've tried to communicate in the release notes and in the progress reports about the HTML API that even DOM document has its issues. Number one, it's an XML parser, and two, it's got a bunch of problems. So in PHP 8.4, finally, for the first time in PHP's history, the language of the web has a parser for the language of the web. The new API DOM/HTML document, there's probably should be a leading slash in front of here, because it's in the global namespace. DOM HTML document is an HTML parser that has the same interface as DOM document, but parses HTML. So like, problem solved, we're done. This is actually coming from the open source HTML library called Lexbor. It's pretty cool. It's fast, it parses HTML the way a browser will, but it's not entirely safe the way the HTML API is. When we got to the point where HTML API could parse HTML documents, we reached a point of, let's call it safety parity, where everything the browser understands, your PHP code is going to understand. But there's a big difference between browsers and servers. And this is where safety becomes blurrier. Because when we're working on a server, we're always working in HTML. We're always working in text. And in the browser, we're working with a DOM tree, a document object model. And in a browser, you can actually construct invalid documents. You can do it with JavaScript. One of the rules about HTML, for example, is that you cannot have an anchor tag, an A tag, nested inside of another A tag. Except in the browser, if you take document.querySelector A, you can create a new anchor tag, a new anchor element, and add it as a child to that existing anchor element. This becomes invalid DOM, but the browser still renders it. It's weird. You can add buttons inside of buttons in a browser. And when we're working with DOM APIs in PHP, we can create the same kind of invalid documents that you can in JavaScript. But there's a problem because we deal with HTML. We're going to see an example in a minute, but there are no possible ways to represent the kind of documents that a DOM interface can create, which is wild and trippy. And it really surprised me the day I found that out. Jumping back a few steps, because I got ahead of myself. I imagine someone in the room has written code kind of like this. This is where I consider like the first level of safety discussion with the HTML API. The HTML API will never split a tag or get lost in an attribute value. But there's two parts of it. There's the tag processor and there's the HTML processor. Or if we want to use the language from the field, we have a lexer and a parser. And the tag processor is what we call a lexer. It scans through the document and finds distinct tokens that should not be broken up into smaller pieces. And it moves from one to the next. The HTML processor then is the parser that takes that stream of tokens and applies semantic rules to say, okay, this token opens up an element, this token closes an element. And it's a common approach to say, like, okay, I want to know where this p tag opens and closes, and I want to get all the content out of the p tag with a certain class name. So we create a tag processor on our document, and we look for a p tag, and we start tracking, and we kind of either add our own little stack or a counter, and we say, okay, if we get another div opening tag, we'll go one deeper. And once we've closed out of the ones we've opened, then we're done. And this works fairly well if you're working in something like code that Gutenberg produced, HTML that Gutenberg produced. Frankly, it's reliable enough because Gutenberg always generates normalized HTML. But the problem is that HTML itself can be unexpected. So if we were to apply this kind of, get inner HTML operation to this input, should we ask how many P elements are in this HTML? Any guesses? Three is correct. How many are inside of the section tag? 1. Because each of these P's implicitly closes the previous one, the section tag implicitly closes the previous one, and a P closing tag, when there's no P opening tag, implicitly creates a P opening tag with no attributes. This is on the fringe. This is why we're talking about safety, and we now are in the really lucky place to be able to talk about higher levels of safety than we've typically been able to talk about with regexes. But the fix is really easy because the HTML processor, just by moving from the tag processor to the HTML processor, resolves that. You can see the code is almost identical. I've only changed which class is being created, and I'm now using this getCurrentDepth. So instead of talking about opening tags and closing tags, the HTML processor talks about depth inside of the tree of HTML. And now the rule is, I think, a lot simpler, because once we get to a P tag, we just look at what depth we're at, and we just keep going until the spot in the document is above that. Like we're either a sibling or we're a parent. That implies the thing was closed. And so same kind of tricky input, no problem. But there's trade-offs. The tag processor is really fast. The HTML processor is slower. It's still quite fast. And actually, when I've looked at a lot of performance benchmarks and changes to core, changes to code within automatic, there's an initial hit for this and you expect everything to be slower, and then you realize that the legacy code is already trying to account for a lot of the complexity and is actually slower than doing the right thing right at the beginning. And speaking of speed, DOM document, or hopefully nobody in this room ever uses DOM document for HTML, but DOM HTML document is much faster than the HTML API. It's a good tool, and it has its place. But let's talk about safety. Here I am, canonically opening an HTML document, loading it up, and I have to add libxml no error to start with, because any malformities in the HTML, it spits out as a warning. And then I just want to get the text content from that document. What's going to happen? I'm running PHP 8.4 on my laptop, and I can't parse this, not unless I give it extra memory for the PHP process to run. I think my default PHP process has 128 megs, and what I've done is I've sent the HTML specification into this, which is like an HTML document that's 12 megabytes. It takes 202 megabytes for PHP to get the text content out of that document. That's the price we pay for having another system build this entire tree. It's much slower with the HTML API. It's not a lot much more code. Any guesses on how much memory the same 12 megabyte document takes for PHP to parse it? Very close. This code takes 21 megabytes, or at least I can give PHP a max memory limit of 12 megabytes or 21 megabytes and get through this. But you know what's even more incredible is that this can actually get through it in 17 megabytes. Because if we wanted to do something like count the words or count how long the text content is, 4 megabytes of this is just the actual string that we're constructing. So 17 megabytes is spent, 12 of which is the document. We did this whole thing in 5 megabytes of PHP code, or 5 megabytes of RAM. So here's a part that really fried my brain, what I mentioned a minute ago. Oh, you know what's funny is I didn't even mean for this to be the trick, but this actually closes this. We get trouble when we start doing DOM operations on the server. So we want to set inner HTML. And I can tell you, this is predominantly the major reason the HTML API in core does not have a method called set inner HTML. This is a problem that we have to resolve. When we're in the browser and we set the inner HTML on that H1 element, it creates an H2 element and puts it in there as its child. There is zero possible way to communicate this in HTML to a browser. The only way to do this is to send an HTTP header specifying the content type of XML, sending an XHTML document which represents an invalid DOM, and the browser will render the invalid DOM. So if you use a DOM HTML document and create this DOM in memory, and you set the inner HTML, what does it do? When you serialize it, it spits it right back out. There we go. Job done. We're good. Except this H2 that it just created when you saved HTML closes this H1. And if you take the output, so parse the HTML, set the inner HTML, save the HTML, and load what I just saved, it doesn't get the same thing you started with. It doesn't round trip. And it doesn't do that because it's impossible to do so. Now this probably sounds overtly technical and specific and nuanced and off in the Netherlands, not the country, but the far distant lands. And you think it doesn't apply to me. But one of the first areas we actually used the HTML API at Automatic was to try and kind of like extract keywords. We have an internal glossary, and when those keywords are mentioned in a blog post, it adds a helpful pop-up to show you what it means. So when you read an article and it says, we've got 14% GQRSTX, and I don't know what GQRSTX is, and you hover over it and it shows it. We started getting errors right away. We looked at it, and it's because we were encountering documents that had nested A tags. And we looked into that, and it's like the old plugin was introducing these A tags inside of the A tags. And I started looking around, and this is everywhere in WordPress because plugin code will find some piece of the document and wrap it in some HTML or insert some HTML, insert a header. And it's actually messed up the whole document. So that's not good. So what do? I don't know. We don't have any way to resolve this issue, but we have 3 options. We can reject the update altogether and say, no, I refuse to set this inner HTML. We can replace it somehow, like maybe we can create a custom element that says what was attempted and change it. Or we can just remove it altogether and take whatever we can extract from it. All of these have weird trade-offs, like if we reject it, you might accidentally ship something to the front page that you thought was going to be hidden and replaced by an update on the server. So you don't want that. If you just remove the tags, it can get weird because you might have CSS that depends on something that you put here. So we corrupt the page. And this one is kind of weird because who knows what the wrapper does. Although this one has a rather interesting feature to it, which is that we can actually reconstruct the broken DOM in the browser if we wrap the tag, because we can have JavaScript that runs and finds these and just changes them. So when we figure this out, Core will have this built in. Until then, we have the rest of this presentation. Probably with Core, what we'll do is we'll have a way for the developer to choose. And it's a lot of experimentation, it's a lot of prototyping and playing with code, writing plugins that use the code, trying to kind of get a sense for how that looks and works and fits in. Because we don't want you to like write a bunch of code and then have to go change it when we change our minds. All right, let's get into some fun stuff. How do we do all these things? Well, I've got a series of techniques that I thought I'd share with you. And again, these are going to be code-specific things. But these are some patterns that I've used quite a lot in my own code. And I wanted to highlight them so that you can go back and mix and match them on your own projects. The first technique is something I call skipping elements. I don't know why it's not in Core yet. I know why it's not in Core yet, but I don't know why, because it's so trivial. The idea is you get to a point in the document and you just want to skip over an entire node. Like maybe I get to a div class equals header and I want to ignore that. Well, it's actually a really easy function that you can write that says if you want to skip over an entire element, basically you just trap the depth and you start a while loop and you just keep going until the depth is above where you're at. In the HTML API, when you reach an opening tag and it enters an element, it actually increases the depth. So like you're in a div tag at depth 3, you get to a p tag, you're now depth 4. I hope that's right. Let's just say you're in a span, so I don't have to remember the HTML rules. You get to that span, it's depth 4. When you get to the closing tag, however, it's back at depth 3. So by the time you reach a closing tag, the depth is smaller than it was when you opened it. That's specifically to make loops like this trivial. That's really handy. I hope you all put this, I hope everybody kind of like subclasses this or adds their own utility classes around the HTML API and adds a skip method. This makes navigating around a document lovely. On that note, a reminder, the HTML API is designed as a low-level feature set of basic foundational tools. It's okay and encouraged to write your own project-specific or company-specific class or library to extend it. Subclasses are interesting. Something I use all the time is the bookmark system. Look, ma, no string indexes. If you have a subclass, you don't actually have to add anything to the core class. You can just add additional functionality. I've written this method 37 times, and I'm working on the 38th right now. And basically what it does is you can just set a bookmark, and that introduces an entry into the bookmarks property, which is a protected member, and a subclass has access to the protected member. And you can just go in there and grab the start and length of the bookmark and substring HTML, and there you go, you get the raw contents. When you're normally navigating through the HTML API, you get the semantic interface, you get the tag name, you get the attribute names, the attribute values, the comment text, the plain text content. But what if you want to analyze the actual raw text to see if, like a shortcode thing, we want shortcodes to have brackets, but we don't want shortcodes to be parsed when we have ampersand, hex, or hash, whatever that is. So you can actually get the raw HTML, which is sometimes useful if you want to do things like extract parts of the document. Only available to subclasses. The coolest thing is serialized token. Has anybody had a chance to use the normalize or serialize interface? What'd you use it for? Cool. A quick refresher. Serialize takes HTML as it's written and spits out HTML with everything normalized. The attributes only appear once, attributes get double quotes, all text is decoded and then re-encoded. I think it only encodes the less than sign, ampersand, stuff like that. So, in this case, we've got, a really long character reference. It's even missing the ampersand or the semicolon at the end, and serialized token. It says, oh, that doesn't need to be escaped, so I'm not going to. It takes HTML void tags that for some reason the internet thinks needs a closing slash, and it normalizes it to a proper HTML void tag. And this is so handy because we're going to look at in a minute what I call my HTML builder, which is entirely built on this. When we want to do inner HTML, outer HTML, wrapping, unwrapping, there's a pattern that I call the builder interface that starts at the beginning of the document, and then for each token calls serialized token, or it modifies the token and calls that, or it skips over it. So if we want to think about how do we remove an element from the document, we just start at the beginning, we start serializing every token, and when we get to an element we want to remove, we don't serialize it to the output, and instead we call skip element. And once we're done with skip element, we keep on going, we keep on serializing. So this is a protected method. You can only call this from a subclass. Maybe one day we make it public. What's public is starting at the top of the document and scanning through it. There's not a lot of need to discuss why at the moment, but it needs to be in a subclass to access it. By the way, there's a really cool thing about subclassing that isn't always obvious. Where is it? Here. PHP has what I think is considered a friend visibility that we see in languages like C++. A static method in a subclass can access protected properties of a variable of the parent class. That's quite a mouthful. What it means is we can create a class that extends the HTML processor, have nothing else inside of it, have a static method on that class that just instantiates an HTML processor the way you might in any other function, but magically now, inside of this static method, even though this is a variable, you can still get its protected members like serialized token and bookmarks. Which is pretty cool because it's kind of like subclassing, but it doesn't. Technically, you're subclassing, but you never create an instance of the subclass. All right, I should have labeled this gist. Let's go to there. Oops. Come on. Come on. There we go. All right, let's see how that looks. Let's see here, just for a moment, in case anybody wants to grab it. I'll put that QR code back up. At the end of the presentation, I'll have a handful of QR codes with links to gists. So this is my serialization builder class, and it's doing exactly what we said. It extends the HTML processor and implements its own new methods. This builder class actually keeps track of the last token. It doesn't immediately, it's going to follow the same process I mentioned a moment ago. It's going to start at the top of an HTML document, it's going to walk through the tags, and it's going to serialize each tag to an output buffer. Along the way, it's going to make decisions about what to do. So we don't immediately kind of like flush the token into the output buffer. What we do is we flush it to a last token, because sometimes when we're processing this stuff, we need to look behind where we just were before we choose what to do with it. So that's what this is doing. In the next token method, it just traps it. If there's something to spit to the output, it does it, calls next token on the parent, and then stores that as the previous token. And we have these series of methods: append, prepend. I don't know if they work, by the way. All the links I'm going to share are probably broken because I don't know how to write code. But I know set inner HTML and set outer HTML work because I did those yesterday. And then I have like wrap and unwrap. And these are like, I think, the set of missing methods that everybody wants. So if we take a look at how bloody easy this stuff is, how trivial it is to do these complex operations. If we want to look at appending HTML after a certain spot in the document, like I want to find the end of this type of block, I want to insert some kind of footer there, or I want to append an add after the third paragraph. Once we come here, all we do is we go ahead and flush out the last token we got to, and then we flush out our updated information, and we move on. It's that simple. Step, 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 insert, step, step, step. For prepending, putting in beforehand, well, what do? Once we get to the element that we're interested in, instead of flushing the token and then putting our stuff, we put our stuff and then we flush the token. Just a couple lines of code. Inner and outer HTML basically work the same way, but they're more complicated. I should have included the previous version of this. Let's see if we can go back. By the way, I sat down at a table and did this whole thing in like an hour last September. It's something any one of you could sit down at a table and make. So set inner HTML. What do? We get to the element, to the tag where our element opens that we're interested in, and okay, what does it mean to set the inner HTML? Well, we take the existing tag that opened that element and we push it out to the output buffer. Then we stick the new content onto the output buffer, and then we move forward in the document until the element closes, and we just don't flush everything inside of it to the output buffer, and then we add our closer. It's bam, 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 done. You'll be surprised in no way to find out that outer HTML is literally the same, except we just don't serialize the opening and closing tag. Boom, boom, boom. Super cool. What's the trade-off? It's slower. How much slower? Probably not meaningfully slower, especially not if we're doing all this WP HTML split stuff. But as we talk about safety and we look at the problem of those invalid edits, the documents that cannot be represented, I think this is so cool. I think WordPress has the chance to innovate here because we have an API for modifying HTML that makes you as a developer aware of these kind of pitfalls and give you the choice of what to do. This probably looks really complicated. I don't want to make dizzy eyes here, but basically, we take this code and we position ourselves in the document. And when we want to make the update, I actually construct a new HTML processor using just the starting tags. So like, we're HTML, body, div, main, whatever. So I reconstruct those using the breadcrumbs, because the breadcrumbs tell us where we are in the document. I pen the new HTML you want to add, and start walking through it. So this is like an HTML processor inside of an HTML processor. And what this does is we're kind of like nesting our serializer builder in here. What this does is it gets rid of those things like the closing p tags that don't belong. Or, someone's put a comment form on your blog and somebody thinks they're real clever, like, I'm going to close the body. Well, in this context, if we encounter that closing tag, it's going to close the parent, it's going to get finished, and we just check, do we have more tokens to process? Like, we finished processing the document, but we have more tokens, which means something went wrong. It's like if this edit were to change the structure of the document in any way, in this case, we just reject it, and we move on. This is the point where we had those three options before. What do we do? Reject, replace, or remove? I had this up with a quick demo, but then my shell crashed. I cannot probably reasonably do this. So I'm not going to try. I'm going to spare you. But if we were to attempt to do the H1, H2 update that we showed in the presentation, I think it just rejects it. It leaves the original content. The important thing is that's up to you. And that's it. Like, done. We can do every single operation that DOM document will allow. And it's in core. You only need a little wrapper class with your own behavior. Zoom through the next few because we only have a few minutes. Sometimes performance really matters. Also, sometimes I want to use the HTML processor to move through a document to where I know the structure. I don't want to get lost when those P tags overlap or the EM and the I tags overlap. But unfortunately, at the moment, a solvable problem that isn't solved at the moment, it's kind of slow to modify HTML with the HTML processor. It's kind of slow to seek around. With the tag processor, you can jump back to a place where you already visited, and you can go back and forth, and it's fast. With the HTML processor, for the moment, that's slow. So sometimes what I do is I crawl through a document with the HTML processor, again, in a subclass so that I have access to the bookmarks. And when I find something of interest, if I want to make a change, instead of telling the HTML processor to make the change, I just create a new replacement descriptor here, this offset, this length, put this content there. And when I'm done scanning through the document, I just create a new tag processor, replace this property here called lexical updates, which it's in the docs, don't worry. It's a protected member. I just transplant those edits from the parent class into the tag processor and call getUpdatedHTML. It just boom, boom, boom. And I know because the boundaries came from the HTML processor that the structure of the document remains stable. I think that's a slick trick. Here's another example where sometimes I want to do the same thing, but my goal isn't to edit the document. Maybe I want to analyze a portion of the document or show something. This is really useful in like debugging tools. If you want to show the difference between the way the HTML started and the way it's normalized. Well, again, we can find a place of interest using the HTML processor, and then we can grab the bookmark, start and end, and when we're done, we can extract the portion of that document represented by our search. So maybe you want to find the full span of a div, which may not even include a div closing tag, right? If we go back to the example with the P's, we want to get that full span. We can do it this way, just by accessing the bookmarks. This is a very brief version of HTML templating function. There's a PR out for it, but we created this concept called a funky comment. Anybody seen one of these before? It looks like a tag closer, but it has a number or a % sign or an exclamation point after the slash. These in HTML are considered invalid tag closers, and they turn into a comment in the DOM. But we expose them as a unique thing, and the purpose is to create HTML placeholders. Because it is a reliable method of introducing placeholders within HTML that cannot break HTML structure the way mustache type syntax or shortcode syntax does. And so the idea here, with an oversimplified version of this function, we just supply a number, and that number represents the positional argument passed to the template renderer. And in the more complete version, we just have a $sign and a name, which corresponds to an array of parameters. And what's really cool with this is it's context aware, so there's no escaping. You never do any escaping. You just supply the raw PHP string, and the HTML API knows that it's inside of an attribute, so it escapes it properly for an attribute. But that's different than how it appears in the markup. The next cool thing there is, once you have this templating form, which, by the way, is a valid HTML syntax, you can save the template as an HTML file and get syntax highlighting in your editors. Your editor may say, hey, look, this is invalid, but it knows where that starts and ends, because every HTML parser in the world that understands HTML knows that this thing is an atomic unit. Won't go into these, but it's very possible and very cool to build state-oriented processors out of the HTML API. I was going to look into some stuff that I've done converting HTML to Markdown, and in the HTML to Markdown link, you can see 3 kind of iterations of that design. I don't think we'll have a chance to look at it. We can look at the HTML builder. I have this HTML grep tool, which I do have a demo prepared. And the idea is, actually I built this while developing the HTML API because the HTML spec is huge and I wanted to search for things. And what this does is it's a tool I always wanted, because if you go to a browser, you can only search for plain text strings. But if you search with a tool like grep on the command line, you get all the HTML syntax. So HTML grep walks through the HTML document and it builds the text content along the way. And it applies your search pattern against the text content only, but it associates the indices of the text content with the actual syntax. So this is able to search for a term in the HTML document, pull it out in its context, even if it spans tags. An HTML element. I don't know if we can do this again without breaking the demo. Oops. Do. Yeah, okay. So now if we search for an HTML element. We can see here that it found the match even though the start of the pattern appears before the A tag. So the highlighting is off because, like I said, everything I share is broken in some way. The point is I was able to knock this out in like an hour, and it helped me find my location in the HTML spec because, okay, it finds this, and now I can see the ID. So now I know, actually I was using this a lot for citations in the WordPress documentation. I want to link back the PHP code to the official citation. Well, I do this, I find the ID, I copy and paste it. There's so many tools you can build when you have this streaming interface. And by the way, we talk about trade-offs. It's not possible using DOM interfaces to parse the first 50 words of an HTML document. It has to parse the whole thing. HTML API lets you do this. This HTML grep tool searches until you hit a max number of results, and then it stops parsing. So if you have a 12 megabyte document and what you want is in the first kilobyte, it's done. It's fast. It's so much faster than DOM document. I also have this really cool thing I built just a couple weeks ago for my taxes. Actually, I had bank records presented in an HTML table, no way to export it. So I wrote this little utility called table to CSV, and it's so stupid. It's so trivial. Take the HTML from standard input, find the first table, walk each row, assume there's no nested tables, and output each cell with proper escaping into a CSV. So for instance, I came in here to this track ticket listing. I just come in here. I'm protected by cookies, so it's kind of a pain to get this through curl. So I'm just going to copy this here, go back to the command line, and I'm gonna paste it, remove a couple rows, run it through that script, and I'm in new shell here. New shell, when given a CSV file, can add this query syntax. So now I can easily, quickly get track tickets in the command line using WordPress. How cool is that? I think I posted another one here if I get out of this. And then we'll end on this, but I just think it's kind of cool. Actually, no, I don't even want to do this. I'm going to take the URL of this browser, this page, this Wikipedia page, and curl it, pipe it into my HTML API table to CSV, and pipe it into that cat so it highlights. And there's a HTML table from Wikipedia as a CSV. I'm going to be at the automatic booth after this talk, so if you want to come discuss specifics or look into things. The Markdown thing is so lovely, and I tell you what, I have been using HTML to Markdown powered by the HTML API to feed context into large language models because it's really good at extracting bits and skipping bits that I don't care about or that will confuse the LLMs. So I'll leave this post up here, this page up here for a moment if you want to take a look at some of those gists. Again, find me at the automatic booth, which is just right outside the door. Thanks for attending. Thanks for your attention.
Thank you, Dennis. And here's from us here at WordCamp Vienna. And I think I know now what I'm going to name my language model to clean up my WordPress options table.
I would like to give one big shout out to, I think it's not on recording, so we can, or are we still recording? Okay, so in that case, give me the mic. I would like to give one big shout out to Dennis and all the team behind the HTML API. You already know that. I gave that shout out to you in August. I used the HTML API for a tool for my company where I parsed a total of 25,000 posts, finding 125,000 links, so hrefs. When you said the other one is faster, the numbers will impress everyone. So really, actual content made by editors, 25,000 posts to find all hrefs, and it took a total of 5 seconds. So 25,000 times new HTML, a new HTML tag processor from post content, parsing to get every single href out of it, just not doing anything else. And 5 seconds is a damn good time. I would have expected anything but not 5 seconds.
Thanks for sharing. Fun fact, I have a library of 300,000 HTML documents that come from the most visited URLs on the web that we run every change against, both for finding potential bugs, but also measuring the performance. So thank you. It means a lot because we care about this. So do we have any question time?
Any more questions around? Someone? Oh, okay.
Enjoy
you
the
so
rest of the
much.
WordCamp.